A very good day. Today, me and my group mates are going to present about the Multipurpose Hall project. My group consists of 4 members, which is me, Timnash Dewi Doctor of Muthusami, Justin Kotek Yuan, Rivashini, and Shazrik.
For the introduction, the multipurpose hall, often known as the banquet hall, is a huge and well-equipped space that can accommodate a variety of events. A well-designed structure can help to limit the risk of costly damage. Construction costs can be reduced by constructing fewer single-use rooms. For the structural design, project is divided into 3 phases, which is first in the planning phase. Various criteria and variables are considered that determine the general layout and size of the project. Secondary elements include aesthetic, society, law, economy, and the environment. Furthermore, the structures and constructions requirements and constraints might impact the sort of building that is built. Next, design phase involve the selection of the most appropriate proportion, dimensions, and detail of structure elements to construct each alternative structural arrangement under consideration. Third, construction phase involve the acquisition of materials and equipment, including transportation from the site, as well as the actual installation on site. If anticipated hurdles develop during this phase, such as a shortage of certain materials or fundamental issues, considerable redesign may be necessary.
Hi, my name is Rivashini. Now I'm going to present about the plan view, front view and side view. Based on the requirements given, we have successfully designed a multi-purpose hall with the dimension of 30 meter in length, 20 meter in width and 8 meter in height. The multi-purpose hall has only one floor with organized designs. The multi-purpose hall has a badminton court, a stage, a storeroom, 2 toilets and 2 locker rooms. So, as we can see from the plan view, the dimension of the elements can be seen clearly. For the badminton court, the dimension is 7 meter times 17 meter in length, and for the stage it is 8 meter and 6 meter in length, and for the storeroom the dimension is 6 meter times with 6 meter, and for the 2 toilet rooms the dimension is 4 meter times with 4 meter, and lastly for the locker room it's 4 meter times 4 meter. So from the front view of the multipurpose hall, we can see that the multipurpose hall is divided into 3 sections. The first section's dimension is 3 meter times with 6 meter in length, and the second section, which is the center, is 6.5 meter in height and 8 meter in length, and the third section is 3 meter times with 6 meter. The dimension of the roof is 1 meter in height and 8 meter in length. The middle section has a front door for this hall. For the side view, we can see that the dimension of the hall is 30 meter in length and 7.5 meter in height. There is also a side door for this multipurpose hall. Moreover, the 3 divided part is, the first one is the toilet, which is the length is 3 meter in height and 4 meter in length, and the second one is the locker room, which is same 3 meter in height and 4 meter in length, and the last one is the storage room, which is 3 meter in height and 6 meter in length.
Thank you, Riva, and hi, I'm Justin, and today I will present about the foundation, the beam and the column of our multi-purpose hall. As we know that the load will transfer from the slab to the beam, and then from the beam to the column, and last to the foundation. So first we will go for the beam. So in building construction, a beam is a horizontal member spanning an opening and carry a load that may be a brick or a stone wall above the opening. So in our multi-purpose hall design, The beam we've used is the concrete reinforced beam, and the grade of the concrete is C35/45. The dimension is 250 millimeters times with 500 millimeters. However, we found that there are some warnings in the Tekla software for our roof beam, so we recommend that we change the concrete reinforcement beam to the steel beam because steel beam is more lighter. And now we go to the column. The column we use is the same as the beam, which is the concrete reinforcement column. So, a concrete reinforcement column is a structural member designed to carry compressive load composed of concrete with embedded steel frame to provide reinforcement. The dimension of the concrete column is 250 millimeters times with 600 millimeters, and the grade is also same as the beam, which is C35/45, and the longitudinal bar used in the column is 8H16. In Tekla, we can find that we have mainly only two types of column. You can see that at the middle part they have a longer column, and beside there is a shorter column. In base of the multi-purpose hall, the foundation is used in our hall, and the foundation type we use is the piled cap. The piled cap size is 250 millimeters times with 250 millimeters, and the length of the pile is 10 meters, which is the standard. And then the concrete class is C32 times with 40, and the reinforce is H25. The function of a piled cap is to create stable foundation and offer a large area for the distribution of a building load onto the pile. And that's all from me, and I will pass it to Dewi.
Thank you, Justin. Hi, my name is Tianash Devi, Doctor of Muthusamy, and now allow me to continue with the slab part. What is a slab? Slab is a structural element that is made of concrete, which is used to create flat horizontal surfaces such as floors, roofing floors, and roofs. So there are two types of a slab, which is one-way slab and two-way slab. The slab that is used in this design is two-way slab. This slab is generally supported on all sides of slabs or beams and whose length to breadth ratio is less than 2. On the ground beam, two-way slab was used and the level that is imposed is 5 kN per meter square. Concrete is used to provide strength, durability, and versatility during the construction of a structure. In this structure, reinforced concrete of a C32/40 with a 200 mm on slabs on beams were used for the first floor. I'm going to present about the next part, which is the load. Load can be defined as the forces that cause stresses, deformations, or accelerations. These loads are applied to a structure or its component that cause stress or displacement. So the dead load in this design is the roof. It has the loading of 1 kN per meter square. For the first floor, it has the loading of 5 kN per meter square. For the first floor uniform distribution load, it has the loading of 5 kN per meter. For the ground floor, it has the loadings of 5 kN per meter square. Meanwhile, for the ground floor uniform distribution load, it has the loading of 3 kN per meter. Now, for the imposed load, the roof has the loading of 1.5 kN per meter square, and for the level load, it is 5 kN per meter square. Now, I'm going to present about the truss. What is a truss? Truss is an assembly of members such as beams connected by knots, thus creating a rigid structure. The truss that is used in the multipurpose hall is the hoe truss. A hoe truss is a truss bridge consisting of cords, verticals, and diagonals whose vertical members are in tension and whose diagonal members are in compression. So, the deflection in hoe truss is the dead and the imposed. So the design value of the dead is 2.2, meanwhile for the imposed is 3.4. So that's all the explanation about the slab, load, and truss. So that's all from our group. Thank you for watching.